today we are going to discuss. So first of all, I want to ask anyone, like anyone interested to talk, like anyone interactive to each other, and what you are expecting from the course, like this class. So from that we can start. Anyone, anyone of can we ask like some related doubts, like what is first of all, what is plant nutrient, what is the definition, and is there anyone interested to talk something, like ask something? Hello. Hello. Am I audible to everyone? Like, hello. Yes, yeah, Vishwardhan already given some response that yes, sir. So you can talk like, okay, like I'm starting with class now. What is a plant nutrient according to your knowledge and what you define, how you define? The people can talk. No need to write a message in the chat box. So if people can write like it directly spoken, it will be better. Like you will get some knowledge and you will get exact definition and it will be useful for you only because the JRF and SRF exam is both clarity and content. It's not about knowing everything. It's how you are knowing exactly. That is a matter for JRF and SRF. Even I cleared my JRF and SRF and PhD also cleared. I cleared several examinations related to agronomy and I graded so many juniors and they got now in IRA also and they got the best institutions in India. So you can participate. I like the two-way teaching, not one-way teaching. So you can talk like Vishnu Reddy and anyone can talk. So like if you're not interested to talk, I will go to the class. Sure, then we will go into the topic and what is a plant nutrient? Plant nutrient is nothing but any substance it's needed for the plant growth and development. It is a plant nutrient. Whatever it is a nutrient like water or air or whatever, it is a plant nutrient. But in coming to the mineral nutrition is nothing but whatever the organic or inorganic ion taken from the soil for the growth and development of the plant is known as the plant nutrient. So, and how this is started, like how all the nutrients are like in soil is having different number of ions and different elements available in the soil, but all these are not useful for the plant. Some of them only useful. So, in earlier investigations from the 16th century onwards, like scientists are found that different hypothesis they are formulated. First of all, one of the scientists in the 16th century, they formulated that water is a sole nutrient and it is required for the plant growth is told by the Francis Bacon. So he expected that for the plants, the water is only the sole nutrient, like the principal nourishment. Without the water, the plants can't grow and it's required around 80 to 90% of the water only and remaining are minerals. But after that, some of the scientists have given that and saltpeter, that is potassium nitrate or potassium nitrate is useful for the vegetation of the growth vegetation and it will improve the soil fertility. It is given by the Gerber. One of the scientists, he started that salt also needed by the plant for growth and development. And one of the scientists, and he given that the sole nutrient itself only the water. It is given by the Van Helmont. These scientists, the four scientists, are like these three scientists are most important in the plant nutrient aspect. They started the earlier investigations into the plant nutrient and its requirement and how it related to the plant growth. They started. And we know that Jethro Tull also given a one hypothesis, but it's after that some days and some years, this hypothesis is not validated. He told that the plant will take the soil as a nutrient for their growth and development. This is called as a tillage, he taught. But in the later years, this theory was disproposed. And exact the development of the plant, nutrition of the plants, it started with uh, the Leibig. He started the soil nutrient and soil chemistry related aspects. So he is known as the father of the soil chemistry, right? Leibig, with with invention of the law of minimum law. Like law of minimum is nothing but that all the nutrients will be in the adequate quantities, but one nutrient will be in the the minimum level. So this minimum factor affects the growth of the plant. It is nothing but law of minimum. It is also known as the barrel concept. So here, so till now, any doubts are there? Like everyone is getting the points.
Sir,
So
can you repeat the soil chemistry, father of soil chemistry?
the Liebig, L-I-E-B-I-G, Liebig. He is a father of soil chemistry. And like
Okay.
one stated, no, right? The Goldberg and the Francis Bacon, the Van Helmont. These three scientists are most important in the plant nutrition subject because, like so in the past years, several questions directly asked who given the what is a soil nutrient for the plants, Van Helmont. Like that, some questions are framed in the previous examinations in the previous year. So you have to remember this all the scientists and their contribution to the plant nutrition. Yeah, then we will go into the direct topic and what is a mineral nutrition. What is a mineral nutrition? The process of absorption and the translocation and assimilation of the nutrients by the plant is known as the mineral nutrition. Means the plant it has to absorb the nutrient and it translocated from the like soil to the plant and it assimilated in the leaves. This entire the process is known as the mineral nutrition. This mineral nutrition. So so here we know that plants are required some 17 essential elements, and out of that, their proportions will be different. So here we will go. The plant body is almost with organic in nature. Means as a carbon will be there as a sole like a major contribution, and oxygen will be there. So how the oxygen, like how the carbon is taken by the plants? Anyone guess like how plants will take carbon dioxide, and how the plants will get carbon for their growth? Anyone can.
Yeah, ionic form, sir.
Like ionic form is good only, but I am asking how they will take in the form of the carbon dioxide they will take from the atmosphere, and some of the carbon they will take from the soil organic carbon. So like 2 by out of the carbon is getting plants are getting from the carbon dioxide. That's nothing but a Hill's reaction in the physiological way, and the remaining 1 by 3 of the carbon they're getting from the soil. So in this way, this carbon dioxide, I mean carbon, hydrogen, and oxygen, these three are the basic elements. Without this, the plant growth, like plant dry matter is nothing will be there. Here, these contribute to 96% of the plant dry matter. Okay, these contributes around carbon, hydrogen, and oxygen. Here, the carbon as well as the oxygen is contributes to 45%, 45% roughly. So around 90% of the plant dry matter contains the carbon as well as the oxygen. And how nutrient, like how plants will take oxygen in the form of in the photosynthesis thing, they will take the carbon dioxide and they will release the oxygen into the plants, right? Like in the atmosphere, they will release, right? Right. Everyone is getting. Hello. Then what are the uh, I mean, anyone knows essentiality of nutrients, the criteria, who given and when given, and what are the points?
Arden
How we
stores.
get the nutrients. So Arnold Stout, he given the in the 1939, Arnold Stout together given the essentiality of the nutrients, but it is again restated and again it's rearranged in a good manner by the Arnold. So these both years are important. In the 1939, Arnold and Stout given the essentiality of the nutrients, like what are the criteria to be taken for the essentiality of the nutrients. So these are the three criteria he given. That is, one is the plants cannot complete their life cycle without this nutrient, and this plant nutrient should be involved in the metabolism of the plants. Is the second point, and third point is the deficiency of the this nutrients can be corrected or prevented only by the supplement of these nutrients. These are the 3 points is given in the essentiality of the nutrients key given, like Arnold and Stout and given in the 1939, and it is restated by the Arnold in the 1954. These 2 years are important, and in some years they asked about this bit also exactly. So here, this is the essentiality of the nutrients, like the criteria how he chosen, and we will take And all the nutrients are all not required by the plants in the same quantity. Some nutrients are required very large quantity, some nutrients are required in the less quantity. So here, based on the requirement of the crop and based on the we are applying the quantity, they are divided into the two types, that is the micronutrients and the minor nutrients. Micronutrients are nothing but we will apply in the large quantity, and the requirement of the crops for these nutrients will be more than the micronutrients. The micronutrients are also known as the tracer nutrients, means they require in the quantity of less than 50 ppm. Okay, so what are the micronutrients in for the plant growth? What are the micronutrients? Like macronutrients are major nutrients: nitrogen, phosphorus, potassium, calcium, sulfur, and magnesium. These are the major nutrients. Again, these major nutrients, based on their essentiality and requirement, they converted into they divided into primary nutrients and secondary nutrients. Primary are like nitrogen, phosphorus, and potassium. These are the major nutrients, and the major in the primary nutrients. So secondary nutrients are calcium, magnesium, and sulfur. They're based on the requirement of the crops. The remaining are like the remaining micronutrients are like iron, copper, zinc, and these are the micronutrients. Like everyone is getting the point. So total, how many essential nutrients are they required for the plant growth? Anyone can answer.
17.
17. What is the recently added element?
Nickel.
Nickel. And who given the essentiality of the nickel? Like these are the some
Brown.
important.
Brown.
And who given the essentiality of the chlorine? Breuer. Like these essentialities also very, very important. Like they are asking in directly question. And who given the essentiality of the iron? If you can answer, like
Gris.
like Gris. Gris. So like I feel discussion is better instead of going for the like it's a normal class. Your people are already reading almost SRD and ready and ready, right? For your like.
Sir, who gave the essentiality of chlorine?
It is given by the
Breuer.
Breuer. Breuer. So this is these nutrient essentialities are very, very important because directly they can ask in the MCQ format. Okay. So these all the nutrients, there are 17 nutrients, and their essentiality should be very, very important. Like for example, who given the essentiality of the zinc? Anyone can answer.
Sommer and Lippmann.
Sommer and Lippmann are given the essentiality of the zinc. And sulfur?
Sachs.
No, that is a
Saxon.
And here we has to see who given the essentiality of oxygen also. Sometimes they will ask. Like anyone can guess? Oxygen. Like everyone knows from the nitrogen to this one that you people are know about major nutrients and micronutrients, but not about the basic nutrients, like basic elements. Who given oxygen essentiality?
Priestley.
No. Theodore Saussure. Like he given essentiality of nitrogen as well as the oxygen. The most nutrients given by the Theodore and Saussure in the very long back. He given this one. And who given the essentiality of molybdenum? This is a basic question.
Arnon and Stout.
Yes. So you should like entire this table should be known, and as well as you people are should mug up, and you also have to understand the what is the requirement of the plants, like what are the levels. The nitrogen level should be the higher and lower as a medium, and what ppm concentration is required for the plants to complete their life cycle. In zinc, what is the ppm, exact ppm, and iron ppm. Like this ppm should be known for everyone, for entire your for your examination purpose. You should know all the things because these are the confusing as well as the very important things. Okay, you should go through this book. These almost these values are there in the SRD as well as ready and ready. Okay, so you can go through this. Then how these nutrients are required for the plants? Like what is the use of these nutrients for the plants?
Vikram, if you want, you can use this annotated whiteboard.
Sir, where it is available, sir? Like
if you want to write anything in on board, you can write. I will give you that.
Okay.
And I am giving you a host. So once completion after ending of the meeting, just end in the Zoom.
Okay, sir. Okay.
Thank you.
Okay, thank you. So based on the function, like here we know like when we will get the board, so we can get into the easy clarity. Actually, I'm not having any board and things, so I can't explain it properly. So all of you are preparing for JRF or SRF? Anyone is there SRF students in this batch? Hello? Shalom. Are everyone getting my screen on your screen? Hello?
Yes, sir.
Yes, everyone is getting right. So like I will tell. Okay, here we know that plant nutrients are 17. Right, 17 nutrients are there in that carbon, hydrogen, and oxygen are basic, right? Like I'm writing here. Actually, I don't have any writing elements, so I'm using like my finger. So here, carbon, hydrogen, and oxygen are the basic, right? Then what are the primary nutrients? N, P, K, right? And secondary nutrients? Calcium, magnesium, and sulfur, right? And what are the micronutrients? Tell iron, copper, zinc, manganese, molybdenum, chlorine, nickel. So these are based on the requirement of the crop. So we divided. So if we will go into the based on the function, the require it will be 4 types we can divide. So one is a basic one, means CHO are the basic, right? And if you take the energy transfer related, energy storage or energy content related are NP. Yes, means like we know, right? Proteins and oil sheets and like protein and everything contains in nitrogen, and the phosphorus is nothing but ATP will be there, and sulfur also in the energy bondage or energy storage it will be helpful. So these are the energy nutrients. And what are some nutrients are for the charge balances like K, calcium, and magnesium are charge balances. And based on the function, these are the charge related activities is done by the potassium, calcium, and the magnesium. And some elements are in the enzyme activation, like all the micronutrients are related to the enzyme activation, right? So these are based on the function. And how like we will apply the nutrients and how it will available to the plant. So is there any ways, or like how many ways are there, like as of your knowledge? How the nutrients are entered into the plant system? Anyone can answer. Like these are 3 ways are there. That is a diffusion process, and there is a mass flow and a root exchange. Diffusion is from high concentration to lower concentration. Mass flow is with help of the irrigation water or any directly. With help of the mass flow, they will go into the plant, from soil to the plants they will take. And the root exchange is like non-mobile elements or enter into the root. Like here, root will be there. Here nearby some nutrients like calcium, like the potassium or phosphorus will be there. So they are taken by the root hairs. So automatically this enters into the root system. From here, because of the transpiration pool, the nutrients are entering into the plant system. These are the 3 ways, that is the diffusion and mass flow and root exchange. So here, which of the nutrients are undergoes the mass flow is a mobile nutrients in the soil. So here the mobile nutrients are nitrate and wait, I'll share the book. So nitrate and sulfate and boron and the chlorine and the manganese. These are mobile in nature. So these are directly grows into the some soil to the plant. They are directly mobile in nature. These are nutrients. These are mobile nutrients. And some of the like ammonium and potassium and the calcium and the magnesium and the copper. These nutrients like ammonium, potassium, and the calcium, and the magnesium, and the copper. These nutrients are less mobile. Means they will move in a very slow manner. Like based on the conditions available, like the moisture availability, or based on the current conditions, the availability will be very lower. These are less mobile in the nature. And then we move to completely immobile elements are zinc, phosphorus, like HPO minus the monophosphate, and phosphorus. These phosphorus and zinc are non-mobile in the nature, so they have to apply in the. I mean, these elements will take longer time to available to the plants. These are the three ways from the soil to the plants will take. Then how? Like I already told, the mineral nutrition. Already told mineral nutrition. It includes the three words. That is absorption and translocation and assimilation. So here the absorption is already done with the help of the mobile nature and immobile nature of the nutrient. The nutrient is absorbed into the plant system. Then how they has to be translocated. Means how this will translocate with the help of the transpiration pool from the roots to the plants and the like stem, and it will take to the leaf area. Like leaf, they will enter into the plant system. So here, based on the translocation, again these are the two types. Here also mobile will be there, immobile nutrients will be there, and some will be less mobile will be there. But majorly we will decide mobile and immobile. So everyone is get like understanding things now. Hello. Hello.
Yes, sir.
Like you are getting my like handwriting right, because I don't have any pen, so
Yes,
I'm
sir.
writing handwriting. So you can like cooperate. So here I'm telling the mobile nature and the immobile nature in the plant system. So if you will take mobile nature, means the plants from the roots to plants, it will go on right, like in the lower leaves, upper leaves will be there. So here the plants nutrients, which are the mobile, they will go into the younger leaves, mobile nature. So if any deficiency in the nutrients, they occur in the lower leaves because this is a mobile nature. So the plant nutrients will go into the younger leaves. So the symptoms will occur on the lower. Means whichever the mobile symptoms, their deficiency occurs in the lower leaves, right? Right? Correct. Hello.
Yes, sir.
If immobile nutrients are there, their deficiency occurs in where? Like where we will get the deficiency symptom in the for immobile nutrients? Where you will you can see in the
Upper part of the plant.
upper part of the plant. But here, like uh, what are the immobile nutrients in plants? Immobile nutrients,
Calcium and boron.
calcium and boron. That and less mobile, and we will
Zinc.
see zinc.
Sulfur.
These are almost important because these visual symptoms see in the middle of the plant, middle leaves. So this is a zinc is important, and the which nutrient is immobile in the plant, and mobile in the soil. Important thing.
Phosphorus. Phosphorus.
Not phosphorus.
Phosphorus.
Phosphorus. What phosphorus? Phosphorus is completely phosphorus. Phosphorus is immobile in the soil but mobile in the plant. So that's why we can see symptoms in the lower leaves. But what I asked is immobile in the plant and mobile in the soil. Which nutrient? We are telling the phosphorus is the wrong way. That is immobile in the soil and mobile in the plant. That is a phosphorus. I'm asking in opposite way. Mobile in the plant and mobile in the soil. Just now I told that is boron. Boron. You can see in the like SRD and radionity that's clearly been mentioned. So boron is mobile in the plant and mobile in the soil. Okay, you remember this point. So you'll see for some bits. Okay, generally people are known about the phosphorus, but boron also important. So, and what are the symptoms are similar to the sulfur? Which nutrient can show nutrient like the symptoms similar to the nitrogen, sulfur? Which nutrient will show similar symptoms like nitrogen? Nitrogen similarity with sulfur. And what is the difference in both? Similar, but what is the difference? Anyone can tell. Similar symptoms will be there, but one peculiar difference is there. What is that one? Hello?
Sulfur deficiency generally show on younger leaves and nitrogen deficiency on older leaves.
Lower leaves, yes. That is a basic difference. And like that, one more nutrients also there. Iron and magnesium also similar. Right?
Yes.
Right or crowd? Similar iron and magnesium. Because this intervenal chlorosis occurs in the iron and magnesium intervenal chlorosis. Means the veins will be in the green color, but in the spaces in between the veins will be in the yellow color. Right? You remember these are the iron, magnesium similar, and the nitrogen and sulfur is similar. These are the similar nutrients. And what are the deficiencies in terms of nitrogen? Most of the plants and how will we show? You people are known or not known? Hello? Hello? Anyone can answer. What are the nitrogen deficiency symptoms? And how will you identify in the plants? Like the simple is like chlorophyll. Simple is yellowing of the leaves and stunted
Sir,
growth.
yellow leaf turns yellow. Yellow leaf
Yes.
turns
And inverted V shape.
chlorophyll occurs.
Yes, chlorophyll occurs, inverted V shape. And what is the phosphorus?
And
Like actively interact, you will get it. Like I feel that if you interact more, so you will get clarity. So you can be confident in examination also, right? So it will better. Like if you are just discussing with people, it will give you more knowledge rather than reading. I feel it will help also. Like you will get a good clarity in doubts. Sometimes what I will ask a simple question, and if you are answering it, very nice. So which nutrient available to the plants in a both oxidized form and the reduced form? Oxidized and a reduced form. Which nutrient in oxidation state and the reduction stage as a major nutrient?
Nitrogen.
Exactly. Even, but yes, right. So like this, if you are having good knowledge and if you are discussing with other people, and what is a reduced form of nitrogen?
NO3 minus.
Reduced or oxidized? Which one is reduced and which one is oxidized?
NO3 minus reduced, NH4 plus oxidized.
NO3 is oxidized form.
Yes, NO3 is oxidized form and NH4 is because these ions are there. Huh? So based on that one, we can tell. So here, what are the symptoms of phosphorus? What are the symptoms? Like option A, yellowing of leaves and purple color, and 3, dark yellow, dark green color,
Purple
and
coloration only.
purple coloration. Or dark green color. Purple coloration is like potassium. Or dark greenish is phosphorus.
Dark green color on older leaves.
There's anthocyanic pigmentation, so you will get more pigmentation. And which nutrient will show hidden hunger? Like just we will discuss. Okay, I think you people have known all of these things. Just we will discuss nutrient related major bits. Like which nutrient will show what is hidden hunger first of all? Hidden hunger is like they require the plant, they require the nutrients, but they don't show. It's known as a hidden hunger, generally shown by the potassium. Right. What is the luxury consumption?
Potassium.
Luxury consumption shown by all the nutrients. Sulfur also will show the luxury consumption. Luxury consumption is nothing but they will take the more amount than the required amount. Right? It's a luxury consumption. They will consume more. And what the like peculiar symptoms of calcium? What are the symptoms in the crops? Like blossom and rot, black scenery. Like these are the calcium. What are the magnesium? Like this, no, all the nutrients, basic symptoms, and what are the popular symptoms or deficiency symptoms? You should get into your idea because several questions they're asking like that. And white bud of maize caused by, and a little leaf of brinjal caused by, and a little leaf of citrus caused by. So these are the major deficiency symptoms, and you have to get idea of all those stuff. Okay. Like, and what are the which symptom, which nutrient will show the deficient symptoms in terminal buds? Which nutrient?
Calcium.
Calcium as well as boron.
Boron.
Both. And which of the nutrients will show dead spots?
What's that?
Dead spots. Dead spots or like spots. That is potassium and the molybdenum. And these potassium and the molybdenum are mobile nutrients or immobile nutrients?
Mobile.
So where we will get the symptoms?
Lower leaf.
Lower leaf. So if you have any doubts related to till now, you can ask. If you have any doubts, like I'm going through very normal. And what are the peculiar symptom of calcium? Peculiar symptom of calcium. This is a hook shape. Hook. You will get hook like this. For example, any leaf is there, so you will get hook like structure. Hook like structure you will get in the calcium. And what is the peculiar symptom of zinc?
Whitening of leaf.
Like leaves will become narrow and small, and whitening will be there, and the top 2 to 3 layers, like 2 to 4, like not in the top, but next to the top level 2, 3, 4, like that, you will get the symptoms, and the leaves become narrow and small. And which nutrients, like what is the boron deficiency shown in the which part of the plant? Is the terminal buds. The both calcium and this one. And so these are the nutrients and micronutrients. And what is a functional nutrient? Anyone knows about the functional nutrient?
Sodium, cobalt, silicon, vanadium.
So vesicona, vanadium, silicon, cobalt, sodium, vesicona. Okay, vesicona. This is a vesicona. Like you can remember, this is a vanadium, silicon, cobalt, salt. So what are the salt required? That is a sodium required plants. Sugar beet, turnip, right? These are the sodium loving plants. And cobalt. So what is the requirement of the cobalt? And what is first of all difference between the functional nutrient and essential nutrient? Essential and functional nutrient. And who given the term the functional nutrient?
Nicole,
DJ
1980.
DJ Nicholas. And what is the difference? What is essential nutrient and what is functional? What is the difference and definition?
Without, sir, if deficiency of essential nutrient, plant cannot complete their life cycle. But
Like which nutrient is follows the essentiality criteria is known
yes,
as essentiality. And what is a functional is it is a functional in the nature, but it's required, it's not required. When if it is required, no, it will complete the life cycle and exact deficiency, nothing we know. It is required for the plant growth. It's a functional in the nature. It is the functional nutrient. So what total number of functional nutrients in the plant system? 21. In 17 plus 4. Right? 21. And people should know, right? What is essentiality, like what are the required plants for example, silicon required in the which crops, and what is the
rice,
no, that is not related to the rice. It is related to
sugarcane, and
like it is required for the plant pathogen resistance and a disease resistance. But Equisteum arvensis, okay, right now Equisteum arvensis. Equisteum arvensis is indicator plant and it is required for their plant growth. And the sodium required for spinach, celery, sugar beet, turnips. And the cobalt is required for the
pulses,
hmm?
pulses,
pulses or legumes. Okay. And what is the ultra micronutrient? Ultra.
molybdenum,
What is the concentration of molybdenum requirement? What is the requirement?
less than 0.2%.
Less than
Yes,
0.5 ppm. Yes. So this is ultra micronutrient. And is there till now you people are having any doubts? You can ask. Like actually, I'm going very normal way. Like I'm not teaching exact in the proportion way. So if having any doubts related till now, have any clarity, any doubts, you can ask now.
sir, is there any specific nutrient in hidden hunger?
Hidden hunger is there. No? Hidden hunger is nothing but potassium. Like in Indian charts are showing the more symptoms in the hidden hunger is potassium only.
Calcium.
No, potassium.
Okay.
And what are the nutrients required for chlorophyll synthesis? Like that functions will be there, no? Like what are the requirements for essentiality and like here I will ask one more good question. So which nutrient it is not involved in the plant assimilation process? Like nitrogen involves in the phosphate, like protein, something it involves in the carbohydrate somewhere, like for example, somewhere it involves in the amines or protein, somewhere it involves in the nitrogen, like phosphorus involves in the phosphatase band, like ATP production. Like calcium involves in the cell wall, magnesium will in the cell wall, sulfur in the for enzymes and activation and like that. So like that, these are having the some assimilation activities. But which nutrient is not having any related for plant assimilation process? Which
Potash.
nutrient? Potash. Potash is not related for anything. It is only for the charge balance and for the transpirational process. It is the potassium is required, and it is also helpful in the translocation of the nutrients. Like potassium gets from source to sink, right? You know, right? Source and sink concept.
Yes.
What is the source and what is the sink? Source is leaf.
Yes.
Sink is our economical product is sink. Like for example, fruit or cob or grain is what is sink. Source is like stem, leaf, and whatever from where we are getting photosynthesis activity is source, right? So and sulfur is required for which crops majorly?
Oil seeds.
Oil seeds,
Oil seeds.
oil seeds, followed by pulses, followed by cereals, and potassium required for the mostly for which crops?
Tuber crops.
Tuber as well as the forage crops.
Yes.
Okay, and the requirement of phosphorus more for which crops? Phosphorus for legumes, for the legumes and legumes, any oilseed or legumes. For the nitrogen fixation, they require more phosphorus than the nitrogen. And calcium loving plants are known as
Sarcophores.
calcifuges means they're very sensitive to calcium, right?
Yes.
And what are the some nickel? Nickel functional activity is urease anhydrase activity. Urease anhydrase, nickel. And the chlorine involves in the chlorine involves in photosynthesis or not? Chlorine, what is the requirement of chlorine? Like, why it is needed for the plant? It is for oxygen evaluation process, right?
Yes, sir.
So, is there any doubts till now? If you are having any doubts, ask me, I will clarify. If it is not there, ask any doubts, I will clarify. Not related to nutrient, related to anything. Hmm? So no doubts till now, right?
No, sir.
No. And how, like, I'll ask you a random question, and how these nutrients absorb the nutrients? Is there any energy requirement? Is there, or without energy they can absorb the nutrients? If energy is required, that is active absorption. If energy is not required, passive absorption. But the most of the 95% of the plants require the nutrients and absorb the plants for passive absorption. 95%. Only 5% is active absorption. Means they spend the energy to absorb the nutrients. Energy. So then we will go to next chapter. Or hmm? Hello. Is a nickel is a mobile nutrient or mobile nutrient in the soil? Hmm? Anyone? Nickel is mobile nutrient or immobile nutrient in the soil. Anyone can guess? Soil. I'm asking about soil. Nickel. Anyone can tell?
Sir, immobile.
Mobile.
Yes, sir.
Why? Guess or you know?
Sir, immobile nutrient.
Mobile. It is mobile. Like we don't know why. But the chlorine is mobile. And then we'll go into exact like nutrients and the fertilizers like that. We'll go or not right now. Or having any doubts ask. And okay, you know what is the required concentration and ratio of fertilizer nutrients required for growth? Anyone know? Like for example, pulses crop 1:2:1, like cereals 4:4:1,
4:1 for cereal.
4 is to 2 is to
4:2:1.
1. 4:2:1.
For pulses,
1 is to 2 is to 1.
1:2:1.
for forage crops, potassium requirement is more. Hence 2:1:3 or 4. Or what is the oilseed crops? Hence 3:2. These are the important ratios for the crops. Like I think you will get in the general agriculture books. And I will ask general and which crops not required any herbicide applications. Which crops are not required any herbicide applications?
The forest crops.
Forage crops, right? And you know, right, what test we will do to conduct the analysis, like soil analysis? No, sir, not. Soil test related activities. Like, for example, nitrogen, which test we will do? Geldal method, right? No, sir, not. Hmm? Hello?
Yes, sir.
Which test we will do? Geldal method. For phosphorus?
Sir, Bray and Kurtz and Olsen.
Based on what? pH level. The alkaline side means
Bray and Kurtz method for acidic soil and Olsen method for alkali soil.
And what are the substances we will use, like chemical ingredients?
Not remember it.
Sodium carbonate for what? And ammonium chloride for what? Brace for?
Sodium, ammonium chloride. For brace.
Ammonium?
Chloride.
Ammonium chloride for what?
Ammonium chloride for Bray and Kurtz and sodium carbonate for Olsen method.
Yes. For potassium, which test you will do?
Sir.
Potassium? Acetate. Ammonium acetate.
Yes, sir.
For micronutrients?
AAS and
Now double A is the DTP extractant.
DTP extractor method.
DTP.
I have to tell the DTP, not the machinery which we are using. That is atomic absorption spectrophotometry is a machine, so it will based on the spectroscopy that will spin the things and it will show the some radiation level like bond length according to that we can tell. And for potassium, sodium acetate. Okay, for sulfur, calcium chloride, right? Hot soluble calcium chloride is extracted with use. For calcium and magnesium, anyone? Ammonium acetate we will test. And boron, which test we will conduct for the boron, like hot water treatment, right? No, 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 no. No. And for molybdenum, we will do ammonium oxalate test.
Ammonium.
Oxalate. It is also known as the TAMS reagent or reagent. Right? Write down if you want. You can write because sometimes they will ask what is the TAMS reagent, and they will ask Peaks reagent. So you can write it down better. I think extract and use for the molybdenum estimation is ammonium oxalate. It's also known as the Gibbs extractant or TAMS reagent.
Times reagent. Sir.
TAMS, TAMMs, double M. And in out of the nutrient extraction technique, which nutrient technique is given by the Indians? Any guess? Wild guess? Anything? Like okay, I will give options: phosphorus, potassium, boron, nitrogen. Out of which techniques given by the Indian scientists?
Phosphorus.
Phosphorus. How?
Yes.
You know, right? The Bray and also names itself is indicating
I think nitrogen.
nitrogen. Yes. Subhaya and Ashita is a technique is given by the Indian.
Yes, Subhasis.
Yes, Subhaya and Ashita. The one technique in India is only given by one Indian scientist is only Subhaya and Ashita, and the remaining techniques are given by the foreigners. And one technique also there, that is ammonium bicarbonate and DTP extractant. It will give micro as well as the macro, both major nutrients and the micronutrient analysis can be done with the single extractant method, that is ABDTPL methodology. Means ammonium bicarbonate plus DTPA. DTPA we already know that micronutrients are copper, zinc, iron, manganese, and all those nutrients are can be extracted with the help of the DTPA with using the AS spectrophotometer, right? And AB ammonium bicarbonate for the phosphorus. So like this, this is a combination of extractants. So from that we can extract the all the micro and major nutrients. So these are the things and their contribution, like what is the concentration of the requirement in the plant as well as the soil. These both are important. For example, if you will take what is the low level of nitrogen level, like if you this much of kg per hectare is there in the soil is known as the low. For example, soil is having 350 kg per hectare of the nitrogen, so it is comes under low or medium or high. 350.
So high.
High? How? Nitrogen is requirement is 280 is low, 280
Medium.
560 is medium, and above 560 is high. So I told 350. So that is in the medium range, right? So medium range. And what is the concentration of zinc required for the plant? Zinc. If it is this concentration is low, and for example, if concentration of zinc in the plant is 0.7, 0.8, then it is comes under what? Low level or high level? 0.8, 0.8 ppm. That is a high level. 0.6 is a limit. Below 0.6 is the low level, and above 0.6 is a high level. So like that, all the nutrients is having these concentrations. For example, molybdenum is a 0.2 ppm. 0.2 means very low. 0.2 ppm. ppm is nothing but parts per million. Means 1 million part. If the one part, like the 1 million population is there, in that 1 year, that's a 1 ppm. That 0.2 means out of 1, it's again 1/5. Means very micro level. So that's why molybdenum is ultra micronutrient. We will call it. The 0.2 ppm is the significance. These micronutrients are required in a very low quantity, but the yield magnitude loss will be more than the major nutrient. Like, understand my point? Like, means what does it mean? If you are applying major nutrients in kgs per hectare, you are getting the yield advantage is like 40 to 50%. But if these micronutrients you are applying in 1 kg or 2 kg per hectare for over a 2 to 3 years of period, if you are not applying these nutrients, the yield magnitude will be more, like 20%, 30% yield reduction will be there. So that is the most important thing in micronutrients, and our farmers are neglecting these micronutrients the most. That's why nowadays the zinc deficiency and the sulfur deficiency and iron deficiency is more prevalent in India, right? And DTP extractant method developed by which scientist? The Lindsay and Narwell. Write it down, Lindsay. LINDSAY, say Lindsay and Narwell. NORWELL, Narwell. And what is the organic carbon method generally used in India? Mostly black, right? Hello? Krishna.
Yes, sir.
You're getting point.
Yes, sir.
Organic,
Yes, sir.
what is the low level of organic carbon? 0.5%.
Okay.
And where you will get more percentage of organic carbon? In hilly regions, you will get more amount of the organic carbon. And where you will get less percentage of organic carbon?
Sir, in arid region?
Arid regions is okay, and most where the erosion is occurred, like eroded lands, because organic matter is having the bulk density is around 0.5 to 0.6. So if the bulk density is less, any erosion is coming, so automatically the organic matter will go. So organic matter is go means the eroded land is having the so lowest early OC content. Like, what is the bulk density of organic soils? That is 0.5 to 0.6 kg per centimeter. Right? What is the general soils bulk density? Anyone? Anyone can tell?
Sir, 1.3, 1.4 gram per cc.
Gram per cc. And what is the particle density? Like, it will be almost doubles of it.
Yes, sir. Almost double of the gram.
Then if it doubles means what is the remaining? Why it is doubling more than double? And what is occupies? What is the difference between bulk density and particle density? Pore space, the porosity. The porosity will be more. Like, this is the gap between bulk density and particle density is the porosity, right?
Yes.
Yes. Porosity of sandy soils is more or clay soils?
Sir, number of pores are more in clay soil. Pore size in sandy soil.
Porosity is yes. Porosity. So till like we cleared general also. So what we will do now? Like, we will continue with the nitrogen fertilizers or the organic matters will go. Nutrient management. Like, till now, like, you understood almost, right? All the points you covered.
Yes, sir.
Like, any problem is there in my teaching? Like, I'm teaching in a normal way. Like, I'm doing in a friendly teaching way. Like, I will do like this only. Like, even my juniors also, like, I taught them like this only. But I used to do in interaction way. Even when I will take the class also, it will be interaction. Don't hesitate that he's asking more and more questions. We are asking the more and more questions is because you should get confidence that yes, I know the point, I know the answer, I know the subject. If you are not answering it, you'll feel you don't know anything, right?
Yes, sir.
Like for that only for your increasing your confidence only we are asking here and more questions to get clarity. Like if you are answering wrong also, okay, you can learn. Okay. And which nutrient test for phosphorus in the calcareous soil? Like which extractant you will use? On options, Olsen reagent, Brand curds, ABDTPA, or none of these out of three.
Calcareous soil, Olsen.
Olsen reagent. So, shall we start? What are the bulky organic manures and their concentrations? It's required.
Yes, sir.
Chalo, then 1 minute. So, what are the bulky organic manures? What is
Sir,
bulk?
it's required in large amount.
Like leave it this. Okay, like I will ask what first. What of all? What is manure? First of all, what is manure?
Decomposed organic matter.
Decomposed or totally decomposed organic matters.
Manures are nothing but plant and animal wastages. Okay, it is in
Yes, sir.
soil organic nature. It's okay, but these are natural made. Like natural means it is a byproduct of any organisms like plant litter or excreta of the animals is known as the manures. General simple word. Fertilizers are chemical terms and it will manufacture artificially. So here the manures are two types. That is bulky and concentrated. What are the bulky? Means they required in the bulk quantity, but the nutrient contribution is very lower, right? Concentrated or application rate will be less, but it contains more nutrients than the bulky nutrients. So here bulky are like FIM, compost. In compost two types, that is rural compost,
Green manures.
green manure, night soil, sewage and flood. Okay, and vermicompost. So these are the methods. Like these are the bulky. What are the bulky? One is FIM, right? FIM. Next is green manuring. Third is compost. Compost is again two types. That is a rural compost and urban compost. And vermicompost, night soil, and sludge and sewage. What is the concentration of FIM? NPK concentration.
0.5, 0.2, 0.5.
0.2, 0.5, 0.2, 0.5.
Yes. Then what is the concentration of compost? Compost.
No, sir.
0.5, 0.5 and 1.
0.5, 0.15,
0.5.
0.5. These are the compost. If you take the town compost, it will be 1.4, 1.4. Like remember, okay, 1.4, 1.4, 1 is 1.4 is like town compost. Compost is 0.5, 0.15, 0.5. It is the urban compost, like rural compost, because we will have more litter and wastage will be more. And here in FIM, What FIM contains? Animal excreta and dung and cow dung and everything, some wastage will be there. And what is the concentration of cow urine? Like nutrient concentration. Anyone can guess? One east, 0 east, 1 east, 1.3. Like cow urine contains 1% of nitrogen, 0% of phosphorus, and 1.13% of the potassium. But here, this urine contains ammonia. It will easily volatilize in the
Atmosphere.
like atmosphere in the where in the animal sheds. So we can use the phosphogypsum or gypsum or superphosphate for reducing the volatilization loss. Right? It will reduce the volatilization losses and it will conserve the whatever the ammonium present in the uric acid, like urine or cow urine. So the which we can use amendments. Which amendments we can use is gypsum, phosphogypsum, and superphosphate. Right. And what is a FIM level available? Like if applying FIM 10 tons per hectare, and it will available for entire crop in the first year, or it will take some time.
More than 60% is available for first crop.
No, out of which 30% of nitrogen available to the first crop, 60 to 70% of the phosphorus and the potassium available for the first crops, and the remaining available for the next year crop. Like
Succeeding.
60 and 30 to 60 to 70% of both. So these are FIM related, like which nutrients we can use to reduce the volatilization losses or nutrient losses in the animal shed.
Gypsum, phosphorus.
Gypsum and superphosphate, we can reduce this volatilization losses. And how many days before we can apply the FIM? If it is a well rotten,
3 to
4
4
to 6
months.
months.
it's a 3 to 4 weeks. It's a partially rotten.
4 to 6 months.
One.
If it is well rotten, you can apply before 10 days or 1 week.
1 week. Yes.
This is a well rotten material. The partial or not rotten material will take 3 to 4 weeks for assimilation of the nutrients to the crop. And what is the general recommendation dose of FIM for the crops? It is a 10 to 15 ton per hectare. Is the general recommendation. Like then if it is 10 to 15 ton per hectare, and what is the nitrogen applying through FIM, and how will you calculate? Like anyone can tell. Like people are understood my point. 10 to 15 ton per hectare they are adding to the soil, and out of which how much of nitrogen is applied to the field? Anyone can guess, or how can you calculate? At least basic idea is there, anyone?
– 25 to 37.5 kg nitrogen.
How?
0.25.
0.5 is there. So each kg, if you're applying 100 kg of this one, so you are getting around what? 0.kg5, like half kg of nitrogen you are getting. So like that you can calculate for remaining entire mixture, you can calculate, right? Hello? Means proportion is nothing but what? 0.5, 0.2, 0.8, this nothing but if you're applying 100 kg of nitrogen, you are getting 0.5 percentage of nitrogen. So what is a 10 ton means? How much? How many kgs? In 1 ton, how many kgs will be there?
100 kg.
Hmm?
1 ton means
Is equal to 1000 kg.
1000 kg.
So if you're applying 100 kg, so you are getting 0.5 kg.
Yep.
You're
0.5
applying,
kg right.
so
10
10,
kg.
so is a 50 kg. Right. But out of 50 kg, it available to only around 30% only available to the crop, like in the first season. Right. So around roughly you are giving around by 2 by 3 is nothing but 17 kg or 20 kg around आसपास में मिलेगा इसको crop को, ठीक है? Like that you can calculate for the requirement of FIM for the all the crops. If you have requirement to reduce the urea recommendation, so how much is applying through the FIM, you can calculate with this technique. And then coming to the compost, so we already discussed the compost is having 0.5 and 1.5 and 0.5 of NPK, and the town compost is having 1.4 and 1 and 1.4. Okay. And here the composting is done with a different method. There is anaerobic method and aerobic method. You right? What is aerobic method? What is anaerobic method? No, or
Yes.
don't?
Yes, sir. Yes, sir. No.
What is the example of anaerobic method?
Anaerobic, sir. Bangalore.
Aerobic method.
Indore, sir.
And what is the days required for aerobic method or anaerobic method? In which method you will get more days to decompose the soil, like in organic matter? Anaerobic method requires a more number of days.
Aerobic method requires more days.
No, aerobic require less days.
Yes.
It's based upon your using the enactment and everything. And one more Coimbatore method is also there. And who given Bangalore method, who given Indore method, that names also important. Even last year they asked for one JRF examination. Even in one recently in an NSC exam also they asked, National Seeds Corporation exam also they asked for the Bangalore method. Dr. C.N. Acharya is for Bangalore method. So their names and how many months it's taking and how they are making compost also important. And then coming to the night soil. Night soil is nothing but what? Human excreta is night soil. What is the nutrient concentration of the night soil? 5.5, 4, 2. Right? Hello?
Yes, sir.
Exhausted? Or you will continue the class?
Sir, how many potash in night soil? How many percent?
2%. 5.5 is 4.2 means 5 is nitrogen, 4 is phosphorus, and 2 is potassium.
Okay.
Okay. Then vermicompost? 3 is to 1 is to 2. But one important thing about vermicompost is not only gives the it gives the major nutrients and the plant growth in PGPR. Plant growth promoting rhizobial microbial population also it will give, and vermicompost it also gives all major micro and micronutrients, and it will give some soil enzymes also to the crop. Vermicompost. And it will also helps in the aeration of the soil, and it will reduce the nematodal population, and it will consume the soil nematodes in the gut. Right? What is a vermi wash? Vermi wash. Vermi wash, all right? The liquid nutriental concentration is vermi wash. And what is then this is a vermicompost, all right? What CN ratio of vermicompost is 16:1. Important, okay? 16:1 to 25:1. CN ratio. What is CN ratio of FIM? Anyone? 10:1 to 15:1, right? That is the CN ratio of FIM. And then sheep and goat manure, what is the concentration of nitrogen and the phosphorus and potassium is 3:1:2. Then what is the CN ratio of poultry manure? 3:03 or 2.6 and 1.4. 3.03, 2:1, 1:4 is the poultry manure. But the disadvantage of the poultry manure is the volatile ocean and the nutrient losses will be more. And here the weed dispersal of seeds will be also less.
So termite problem also will be poultry. Termite problem?
No termite problem here. That if you use the poultry manure, you can reduce the weed loss also. Like weed seed dispersal is completely less. In FIM, what happens is in FIM we are using the all the crops, like all crop residues we will use. So the seeds will germinate in the field. Like some weed dispersal comes from the FIM, like not well rotten material. But in poultry manure, what happens is everything is well rotten, and that so when the weed seed is processed through the gut of the chicks, or like chickens are poultry, so it will completely, its viability is completely lost, so it won't germinate in the field, so completely weed dispersal will be completely zero. But the one problem with poultry manure is around 30, within 30 days the 50% of nitrogen will be lost. So when you are applying poultry manure, you have to incorporate in the soil as soon as possible. We should not waste the time like FIM. In FIM we will take 2 to 3 weeks, or 3 to 4 weeks we will keep the poultry man like FIM in the field itself. After that, we will mix into the soil. But in the poultry manure, you have to mix when you are applying the next week only. You have to, like within next 2 days, you have to incorporate in the soil. So these are the bulky organic manures, and this concentration in NPK is important, and especially vermicompost is important bit, because the rich bulky organic manure is providing both micro and major and micronutrients is only vermicompost. Remaining will give only major nutrients in the higher concentration. And their CN ratio also important. They have to get CN ratios for all the manures. And coming to the green manuring, so we will detailedly study in the later. That's green manuring is two types. That is excitive green manuring and in situ green manuring. In situ green manuring is we will bring the we will grow the green manure crops itself in the field. We will, after 40 to 45 days, at getting in the pod flowering stage, we will cut down and we will mix in the soil with the trampler. It is inside the green manure. Except the green manure is like glyceridia or some any subabul. These plant leaves will bring from outside, and we will fill in the, like we will use the leaves as a manure to the field in the, this is a exciter, means from external side we are bringing the green field manure. This is a exciter. These are both two terms. Green manure is two types, exciter and the inside. So these are the bulky organic manures we will use, or bulky manures. Then in the next class we will concentrate on the concentrated manures and the organic, like inorganic nutrients like fertilizers. We will go into study. And till now, people are having any doubts, can ask. If having no doubts, we can wind up the class. So next time onwards, I will bring the PPT. So it will be better for you people also. You can directly see, like if you are, like I thought it will be like you people are more interacting, but like okay, one or two people are interacting more, so it's a very encouraged and appreciable. And so next week, next class onwards, I will use the PPT mostly, so it will be easy for you people also. So can we wind up now? Okay, if you tell sir will wind up means will wind up. You having any doubts, you can ask. Okay, then we are winding up. Thanks.